Welcome to my presentation today. When I honestly inherited this title and the presentation from a colleague, so I thought roads in Europe, that's going to be a nice little presentation and do some digging and researching on European strategies for infrastructure and road projects. I put it together with some case studies and that's it. So I started my research and pretty quickly I got really confused about the European strategies. And the best thing you can do when you're confused already, keep digging for more information. So it's the result of this gave me the agenda of the presentation today. So this is, I offer you a glimpse into the pool of information I gathered, how to understand all those strategies, those plans, those laws, directives, regulations, whatever is out there. And I would like to offer you the opportunity to get in touch with me and let me know, what do you think? Did you also got the same conclusions than we did? So I look forward to focus today on the regulatory framework in the European Union. And then we will look also at balancing environmental impact. And at the end, we will look especially as well on the sustainability of geosynthetics and roads. If you start doing your research on European regulations, the first thing you will find is the European Green Deal. We heard it in many presentations before. So we are trying to be the first climate neutral continent. And the European Green Deal is therefore the implementation of the Paris Agreement. And it's implemented by EU regulations and directives. So it creates legal obligations for member states. So even if you're not from a very progressive country such as the Netherlands, you have to keep sustainability in mind because it will be law in the future. In 2025, so end of last year, the Clean Industrial Deal also came into place. There were complaints that it sacrifices some of the sustainability goals for the sake of relief for industrial stakeholders. However, the EU insists that the climate objectives stay consistent, such as the climate neutrality by 2050. I was also wondering, what are the implementation tools which have the biggest influence on our work in the construction industry? No matter whether you're a contractor, you're a designer, you're geosynthetic or construction product manufacturer. And I found out that the Corporate Sustainability Reporting Directive is quite important, as well as the Circular Economy Action Plan. So this is what I want to talk you through today. Let's start with the Circular Economy Action Plan. The main objectives would be that products should be more durable and repairable, and also recycling should be supported, as well as the promotion of secondary raw material. Secondary raw material is the new word for recycling materials. And we heard before it was 30% of the entire consumption, energy and resource consumption in the European Union. I found the number about 50%, even more. So the construction industry really has to look into sustainability. And the measures in this context, which affects all of us, would be the integration of environmental indicators, as we have heard already a lot about it, the promotion of EPDs. Jürgen mentioned them shortly. I will also show you a little bit about that. And a big part, which was also discussed this morning already, the revision of the construction product regulation. This is the revised version of the construction product regulation. It's already in place since end of 2004. And what you find is, let me start with this. So this regulation is the basis to obtain CE markings for construction products in the European Union. So if you don't comply with this, you won't get a CE marking. In this regulation, it was also the basis for the so-called Declaration of Performance, which is now changed into the Declaration of Performance and Conformity, which will include the environmental sustainability performance. which is quite interesting. So it won't not only be any longer for your technical parameters, it will also include, as you can see, actually from January 20, excuse me. It will also include climate change effects from right now, in fact, from January. So what does happen? So we can state that the CPR transforms sustainability data into regulated product features, which is quite a good thing if you would like to push the sustainability. There will be a delay because you not only have the construction product regulations, you also have the harmonized standards, which also need to be updated. Until all those harmonized standards are updated, the DOPs remain relevant and the old product regulation, which is the product regulation with the number 305. And you will see there is always some push into the right direction of sustainability. So it should notably take into account, and also the use of environmental product declaration is already encouraged. But there's no must, as it will be quite soon in the future. The EPD, we have heard about it a little bit. The EPD is a document which transparently communicates the environmental performance or impact of any product or material over its lifetime. It's very important that this is a third-party verified document. So no construction material supplier can do their own EPDs. It must be a third-party verification. And also, if a product holds an EPD, does not necessarily mean that it's an environmentally friendly product. It only says the product has been assessed based on those information. And also, there are the guidelines we have seen also already before. And this is what we have seen in Wim's presentation already. This is the life cycle from A1 to actually life cycle phase D. We will later circle back to the EPDs again. But now we would like to go to the Corporate Sustainability Reporting Directive, CSRD. So this is, or this will be, or already is, a mandatory sustainability reporting. The importance is equivalent to the financial reporting of each corporation. It came into force in 2023, and this year would be the first year where reporting companies have to report on the environmental, social, and governance sustainability. And it's also part of the European Green Deal. It should increase the transparency and the comparability in integration of sustainability into corporate management. So large construction companies, especially infrastructure operators, building material manufacturers, and industrial groups will have to report. There has something been which is called the omnibus package. To relieve some industrial stakeholders, the criteria were lifted. So before, in the first draft of the CSRD definition, it was that companies, I think, with 500 employees need to report. Today, which was quite recently, end of February, published, it's now lifted to 1,000 employees and over 450 mil net sale. So as you can see on the graph on the right-hand side, the numbers of reporting companies was reduced from multiple thousand in some countries to only a few hundreds. But still, there is something like what is called the trickling down effect. There will be reporting companies at the top, but the information they require is requested from medium-sized and smaller companies along their value chain. And this has something to do with the way those balances are made. So no matter whether you're an investor, product supplier, a design office, you will be asked for information. Because this has something to do with the way those balances are made, which is the greenhouse gas protocol in most of the times, which is alternative to the ISO. So it's very comparable. And it's compatible with the CSRD. What you can see here is that there are actually 3 scopes considered. The first scope would be what you have inside your company, the company facilities and your company vehicles. Maybe let's go here. The scope 2 would be indirect energy emissions, emissions from purchased energy, like electricity, heat, steam. And then, very interestingly, the scope 3 is all other indirect emissions along your value chain. That means everything, if goods are purchased, if goods are transported, everything you can see on this graph will become the input of a scope 3 of a reporting company. And this, and for infrastructure project, this is even extended by what is so-called external effects. We will see this later as well. So if you're working in a design office, this makes you a very special, that brings you into a very special position, because design decisions become climate relevant. So very early in the process of a project, you will be required to share those data, because construction type, material quantities, construction method, construction time and traffic restrictions, all is somewhere the input of your project owner, if this owner needs to do the reporting. And also, for me, working for a geosynthetic manufacturer, this also, did I do something? This also means that we need to get those data of our products, like EPDs, LCIs, CO2 data. CO2 data, information for recycling, everything is needed because it's somewhere in scope 3 of another company. So this is what we call the trickling down effect, those cascading effect which results from that. But if we have those data, we can also do nice things from it. So we could do, as we have seen today, very beautiful examples of geosynthetics bringing special benefits to your construction projects in terms of environmental impact. As this was done in a pilot project at Stockholmer Straße. If you have seen any presentation of my colleagues lately, you probably have seen this before, a bridge abutment close to the Dutch border, in fact. But I don't want to bore you with the technical details, because you're all very well aware of how to design a geosynthetic reinforced structure as a bridge abutment. I would like to jump directly to the life cycle assessment, which was analyzed here by Fachhochschule Münster and Kiva. There were 3 options analyzed: the conventional reinforced concrete abutment, also the abutment with geosynthetic construction, under the assumption that it was a thermal recovery, which is also a fancy word for burning the geogrid after its use, and the abutment under the assumption that we could recycle it by 90%. This is the result. And we have seen this also aligns very nicely with the case studies we have seen earlier, that there is a significant reduction of geosynthetics. As you can see at the graphic, you will find all those life cycle stages from A1 to D. And we can see that most of the carbon footprint results from A1 to A3 for all options. But there's also a significant reduction of geosynthetic solutions compared to the conventional solution by 40%. What was very interesting in this project, that there was actually the construction time and the influence on the traffic. So this is a motorway. So there were no restriction of traffic on the A3 during the construction work itself. There were only 2 full weekend closures required when the bridge was placed on when the bridge deck was placed on top. And this is interesting because we have heard before that in our environmental balancing, there are also so-called external effects that could be included. And those can be the risk of accidents, more emissions because the cars go slower, more traffic jams, diversions, noise. And this is a beautiful study from Matthias Müller from Karlsruhe in Germany. And he did not do the analysis for geosynthetics, but for bridges in general. But I think all the methods can also be applied for geosynthetic solutions. But what he found was that there are life cycle costs, structure related, as well as external effects related. And this is quite interesting that all those effects, like because you have to change diverse traffic, you have reduced velocity of your vehicles, that all has a major influence on the results for your life cycle costs. He also presented a model. It's all building informational model based. So it's a very sophisticated way of doing all those balances in an automated manner, which is, I think, a very intriguing approach to do that, so that the external total cost of a construction can very easily be calculated using those methods. And there's also a monetizing approach connected to that, what you can see on the right-hand side. So I was wondering then, when we have clearly benefits using geosynthetics, when we have clearly benefits in construction time and all this, where are, in Europe, all the project owners who wants to have sustainable solutions? What's going wrong? Why we haven't seen an increase of demand for geosynthetic solution? So does it have something to do with procurement, was my question, which led me to the next strategy I found from the European Union, the green public procurement. It's not mandatory under EU law, but it explicitly allows environmental criteria and life cycle costing for procurement methods. So, but the problem is, across member states, the level of introduction or implementation really varies a lot. And I was also surprised first. I thought it was a funny incident that the color scheme from the green public procurement is quite similar to the NGO. But then I thought, no, it can't be a coincidence, because you are actually living in a quite pioneering country, because Netherlands is the only country that connected the methods for doing life cycle assessment and carbon footprint analysis with the monetizing approach. So this is very unique in Europe. As you can see in other countries, like I think Sweden is a good runner-up. The other ones, like Germany, Spain, UK is here as well, unless it's not EU any longer. So there are tools, but it's the Netherlands is the only one with the MIK that Wim nicely presented who can do that. And the other countries in light blue and gray here, they just open some strategies, or they have made the general GGP strategies, but no further step. So while we're waiting for all those countries to catch up, so maybe we can send Wim to each and every country in the European Union to explain how this is done properly, so that we really get the laws and get really get going with this. We could use the time to put ourselves to the stand. So, okay, we are better than others, but can we do even better than we are right now? So then we go back to our pilot project and look, where does the emissions within the geosynthetic reinforced structure come from? So here it was a special case. There was also a hydraulic binder in it, which can be removed because we know we can build geosynthetic reinforced structures without an hydraulic binder. This was some conservative German checking the design and wanted it, but we can do without it. So when we then only look at the geogrid, and the colors represent again our life cycle stages, so we will find that a high proportion of our emissions come from A1 to A3. So really the manufacturing phase, the geogrid itself. And the other proportion is the waste processing. So the big question is, how can we improve the sustainability of A1 and A3 to a C3. So what can we do? And I think we have discussed it earlier. Everyone has already a little bit dipped into it. We could, for instance, we could explore options of using recycled raw materials, biodegradable raw materials. we could explore options for reusability or product recycling. Biodegradable raw materials at the moment have the big problem that they are biodegradable. So for reinforcing things like for bridge abutments, for slopes, we want to have a precise prediction of our strength for a given service life. And the biodegradable raw materials at the moment can't provide us with that. But of course, there is a lot of research going on, and I hope there will be another solution. What about recycling raw materials? There was a short discussion this morning with Professor Körner's presentation. And what about, and a question from the audience, how about recycling raw materials? When thinking about reinforcing products made from PET, we have a very beautiful thing of PET, which can be very useful, that polyester is a polymer in which recycled fibers exhibit the same chemical and mechanical properties as virgin fibers. So if we look into it, for example, for this tensile strength test, we are not able to distinguish between the products of recycled fibers or virgin fibers. And also there are already predictions about the service life and related to creep and all those long-term analysis. So actually we would be ready to go with recycled, with material made from recycled fibers, but there is a catch. We also catch this, we already talked about this morning. The catch would be the harmonized standards, exactly the ones that need to be updated for our construction material product regulation. And this says that materials with the service life up to 5 years can be used of virgin fibers. If we look into the long-term applications of a reinforcing product, a product consisting of virgin polymers, that means until now we cannot get a CE marking for a geosynthetic made of recycled fibers for the use of more than 5 years, in fact. So, luckily, this does not apply to asphalt inlays because this is another harmonized standard. So I can show you an example of an asphalt inlay made of recycled fibers from the eastern part of Germany. So here the asphalt overlay and the asphalt binder were removed in order to rehabilitate this reflective cracking, what we do with asphalt inlays. So it was removed and asphalt reinforcement made from recycled polymers were installed. And if we go back to the idea of an asphalt reinforcement, which is to extend the service life, the use of an asphalt reinforcement is already a very sustainable idea because we can extend service life, and if we can combine this with a recycled material, gives us even higher benefits. How about recycling of geosynthetics? We have seen it. There's also research going on. The big challenges at the moment are that we have a destructive removal. So we need a very careful excavator driver who pulls us off the geogrid from where it's used. Then there is mixed material composition. So if the geogrid has a coating or some additives added into the mix, it's really difficult. It makes it more difficult to recycle. It's easier if there's a single origin polymer. Then there is contamination from soil. We have heard about it. We have to clean the material. And there's also a lack of collection and recycling points. So what would be required is a network all over Europe where you can bring your geotextile for cleaning, for shredding, for reuse. Current regulations, we have heard about that already. So the reuse of geosynthetics, that would be quite suitable or quite ideal for temporary roads, especially for the power line constructions. They're repeating the work every 100 meters and for kilometers. So it would be such a great idea if they can just reuse the geotextile. However, again, we need a careful removal. And also we want a very high resistance against installation and removal damage multiple times. And most of the time, if we know we lose strength by installation damage, we add strength to it. But of course, we don't want our products to have too much strength, because strength means additional weight. Additional weight means more CO2 while transporting. So we don't want that the benefit is eaten up by the additional weight. And we don't want the material to tear in thousands of particles, because then we get the problem of microplastics and all this. We want a nice coherent material, which is also the ongoing research looking at. Then we're at my summary already. So the European Sustainability Framework allows and encourages tools and guides to apply environmental criteria and life cycle costing for road infrastructure projects. However, the update of the harmonized standards will cause a delay of the implementation of the CPR 2024. And we would also require an update to allow the long-term application of secondary raw materials for geosynthetics with reinforcement function. The Corporate Sustainability Reporting Directive we looked into influences smaller contractors, designers or manufacturers due to the Scope 3 emission of project owners and the so-called trickle-down effect. The incorporating of the Green Public Procurement directives into national laws varies across member states, and this is something we really would like to change quickly. But while we are waiting, I think all the other speakers today have shown very nicely that they are very interested in even improve the geosynthetics to tackle all challenges that come with climate crisis. So let's get ready to collect and assess environmental data for geosynthetics and explore options to further reduce the environmental impact of geosynthetic solutions. We have all one common goal, and I think it's time to start.